Today, I have the pleasure of speaking with Dr. Carolyn Myers from FendX Technologies, biotech, a sector we are watching. And you had breaking news yesterday about a breakthrough in nanotechnology with a film that repels and kills bacteria. How about I let you tell our audience how important that news release was? Thank you.
Yeah, well, let me just tell you a little bit of the background. We licensed the original technology from McMaster in 2021, and over the next 2 years, it was clear that we needed to reformulate to put together a nanotechnology formulation that would be amenable to scale up. And so, in collaboration with McMaster, that's what we did. And so one of the formulations that we came up with was one that both repels and kills. I mean, our original formulation and the one that, we are currently moving forward in production with Dunmore, our film manufacturer, who's doing scale-up development, is a repel film. But through this whole process, we discovered this film and components of it that actually kill as well as repel. And what it encompasses is a product that has a photoactive nanoparticle in it. It's called titanium dioxide, TiO2 is what it goes by. And not only does it work as a linker in the whole chemistry to create the repelling surfaces, but if you put it if you expose it to light, just regular light or UV light, it also kills. So our films, as it relates to repelling, they repel quite significantly. This publication actually showed that the combination of TiO2 and fluorocarbons to make our surface repel or prevent adhesion of bacteria by close to 99.8%. So that's pretty close to 100%. But if you do have residual bugs, so that other 0.2%, it will kill those bugs up to 99.6%. So surface is almost like, invincible, like nothing will adhere to it. But just by virtue of the fact that these surfaces repel by close to 100%, in this particular case 99.8%, we're still going to continue down the road of developing REPELWRAP film, which is the product that just repels or prevents adhesion of bacteria and viruses quite significantly. But in the background, we'll still be looking at this repel and kill version as we move forward. So we're pretty excited about the results, and that's why we put them out, because quite frankly, I don't know of any films out there that repel, first of all, but also repel and kill. And potentially the combination might be better than a repel version or a kill version of films. But, we're getting pretty good results with our repelling properties today. So that's why we're going to continue moving down that road.
And for those of you out there with your pen and paper trying to put this all together, let me just reinforce what Carolyn has just said, which is basically, and correct me if I'm wrong here, this is a specific mechanism where you take your photoactive nanoparticles and the fluorosilane, is that pronounced properly?
Yeah, fluorosilane or fluorocarbons. Yeah, it's a fluorocarbon combination, yes.
But these are basically activated by light exposure, and film, and they work together to both repel and kill bacteria, which is really the exciting and competitive advantage that we're talking about, not to mention the percentage of reduction in bacterial adhesion. Is that correct?
Right. Yeah, so let me just explain how this works. So basically you have your film, which is like the equivalent of Saran wrap, right? And what you do is you activate the surface of that film, and then you attach the nanoparticles. And in this case, we attach the TiO2 to it. And then on top of it, you put the fluorosilane. And then once the chemical reactions have all happened, then you heat shrink it, and that's what creates the surface. So You can use, and the TiO2, they're called linkers. So it's linking the fluorosilane to the actual film. And so there are all kinds of different linkers you can use. I mean, originally we were using Aptes, which is, I'm not even going to tell you what that is because it'd take me 5 minutes to say what Aptes means. But, we're also looking at other linkers. The fluorosilane is really important from the repelling standpoint. It is very important, but you need all of these components together in order to make that surface with the properties that we desire, which is this 99.9% prevention of adhesion of bacteria.
So, can you tell us how the film's efficacy in reducing bacterial contamination compares with existing surface protection technologies, particularly in high-risk environments like hospitals?
So there are other films out there, and they work very differently than we do. They actually kill bugs on the surface. They all have some sort of either photoreactive or metal ions in them. The ones that are probably most known are ones that have silver or copper in them. And those surfaces are known as being antimicrobial, that when the bugs actually stick to the surface, because they can stick to the surface, and they start replicating, they will be killed by the metal ions. Whereas ours, because they can't adhere, they can't replicate, because they have, the bugs they have these little feelers that they have to hold them to the surface in order to replicate. And if you can't attach to the surface, you can't replicate. And so in our case, because you can't replicate, the level of transmission is significantly reduced. With regard to the other films, because they are killed on the surface, they do have to replicate. And so what I've always said is that there's still a potential window of opportunity that you might get transmission, and cause the bugs to be transmitted to between person to person. But at the end of the day, those films are also very effective. They've shown that they can reduce. They can kill up to in the high 90s as well, but it takes time. Whereas ours, again, nothing sticks to it, and instantly. So as soon as something tries to attach to the surface, it can't replicate. And so that's the foundation of our technology, and why we're so excited about moving forward with it.
Well, certainly. It does sound incredibly exciting. Our investor talk audience was very excited about the wide-ranging applications. And with the ongoing development of the REPELWRAP film, what are your anticipated applications of this technology in commercial and public settings? And can you comment on when this is expected to be widely available?
So we're developing two different products. One is a film, and one is a spray-on of the film. The spray-on of the film is a little bit earlier in development, and our film is our lead product, which currently is with our manufacturing partner, Dunmore International, where they're doing the scale-up development work. And you may know, I mean, part of the reason we started this whole company was actually not because of COVID. I hate to say it, but it was because of the fact that there are a number of pathogens that thrive on surfaces that, if they are transmitted, they can cause disease and potentially kill people. You probably know some of them: MRSA or MRSA, C. difficile, and others. Some of the E. coli strains also, can be very virulent, and potentially kill. So, so that's the reason we started the company. Our film, the idea is that we'll create films of different sizes and shapes to go on door handles, to not knobs, but door handles, and on railings, on flat surfaces, to protect those surfaces. And we are really excited about the spray because if we get to the point of being able to scale it up, we anticipate that it will be easier to apply and expand the opportunities beyond what we're looking for with REPELWRAP film, which initially is healthcare, potentially other high-touch surfaces and other high-traffic venues. But the spray may be able to apply to, number one, more high-touch surfaces like actual doorknobs, taps, etc., and potentially go beyond high-touch surfaces in terms of applications.
Well, I just want to add one more item, that I heard you say in a conversation recently with some investors. You have been involved in building some very successful companies, and you were disclosing the organic growth pathway you're setting for FendX Technologies, but you also included the fact that your background includes a very successful M&A licensing experience. Can you talk to our audience about how this may impact your role as a CEO for FendX and how you may integrate that into your existing role?
Yeah, good question. I mean, it's one of my passions, right? I've done a lot of work in the M&A and licensing area, having worked in senior roles in some of the large cap pharmaceutical companies in the corporate office. And what I know from having been involved in these companies and looking for external opportunities is that you cannot grow just through organic growth. Like we have a pretty nice pipeline, but I know that you need to complement it with potential M&A or licensing opportunities, which is what we're doing now. We're exploring a few opportunities that we may bring into the company, and hopefully we'll be putting out some releases in the near future with regard to that. And what we're looking for are products for acquisition or licensing that will be complementary to what we're doing today, which is really preventing the spread of potentially lethal pathogens and just under the umbrella of infectious disease control is what we're really focused on. So having done a lot of M&A and licensing in my past, I've probably done 50 plus deals, some sort of various transactions. I know this area well, and again, it's one of my passions, and in my opinion, absolutely essential to success of any company that wants to continue to grow.
Carolyn, thank you so much for joining us today. And remember, FendX Technologies repels and kills bacteria. If that doesn't make you go to their website, I don't know what does. Thank you so much for joining us today.
That was great, Tracy. Always nice to join you.